Alright, so let's do some of these problems. They're telling me that this is from page, let's see, this is from page 121 in the textbook, okay? So we're told about, let's see, a sleep study. We know that the average number of hours of sleep is 7 hours, and the standard deviation is 1.25 hours. So now this is for all people. And so this is a population mean, mu, and that's a population standard deviation, sigma. Okay, so that's because we know that we're going to be working with the z distribution for this problem. So they go out and let's see, they sample, what are some other elements here? They tell us we've got 50 college students. From that 50, we find out their average amount of sleep is 6.2 hours. Okay, and they're telling us to use that population standard deviation. All that's saying is you're going to be using z-scores, not t-scores. So what's the point estimate for the average amount of sleep for all college students? Well, that's what the sample average is, 6.2. Okay, that's the best guess based on this sample. But now we want to come up with the estimate, a better estimate, so we're going to construct a confidence interval. So for a 95% confidence interval, I see this is a mini table from the normal curve table in the back of the book. I'm seeing for a 90% confidence interval, I want to use a 1.645. Now, why do we do that? Why do we use that number? Where's that coming from? What you got to remember from your work from the central limit theorem is that we know that these samples, if we go out and take a whole bunch of samples of size 50 and find the averages of each of them, those samples will fall in a normal distribution around that true mean. Of course, we don't know what that true mean. Remember, this is the mean for college students, not for the general population. Okay, so we don't know what that mean is, but we know that all these different averages, all these different samples are gonna be centered around whatever that mean is, and they're going to form a normal distribution. Okay, and we know if it's a normal distribution, we know if we go according to this table, if we go 1.645 standard deviations below that mean, and 1.645 standard deviations above that mean, that'll account for 90% of all those samples, and that'll give us a good estimate of what this unknown average is. So to get this confidence interval, we're just going to take that sample average and move things down just a minute here. Let's see. We're going to use that formula, the sample mean plus or minus the margin of error, and the margin of error is found by taking that z, that critical value of z. Actually, this textbook doesn't use the star, does it? It uses alpha divided by 2. Well, that's just saying if we're looking for a 90% confidence interval, there's a 10% chance we miss it, half of it's on each side, and that's where we're getting the alpha divided by 2. Okay, the 5% on each side. And since they gave us this little mini table, we don't even have to worry about that. So the formula, go back to that formula. So it's x bar plus or minus that z, whatever that's going to be. For this one, it's 1.645, times the standard deviation, the population standard deviation, divided by the square root of the sample size. Okay, so what do we know here? Well, we know that the sample mean was 6.2. We know that the z-score we want is 1.645 for that 95% level of confidence. And then the population standard deviation is 1.25 hours. And we're going to divide that by the square root of the sample size, and this is a sample of 50 college students. So to calculate this, I would find the square root of 50. That is 7.0711 about. Now I'm going to take 1.25 and divide it by that number. That's giving me 0.1768. Now I'm going to multiply that by that z-score number, and that'll give me the margin of error. So I'm getting 6.2 plus or minus 0.291 I'm going to round to. And then to get your limit, so for part B it says find the confidence interval. I'm just going to take 6.2 and subtract the 0.291. That'll give me my lower bound. Then to get the upper bound, I'm just going to do 6.2 plus the 0.291, because this is the margin of error, right? That's the wiggle room either side of the mean that will account for 90% of the samples for this level of confidence, okay? Now, the only thing that changes for C, I guess it doesn't for C. Now we're supposed to answer. Does your answer to the problem support the claim that college students get less than 6.5 hours of sleep on average? Well, I guess I better do this calculation then. So doing that arithmetic gives me this answer. So I'm 90% confident that the average college student will get between this many hours of sleep. And this is less than, my upper limit is less than 6.5. Barely so, though. And of course, that's at a 90% confidence interval. So, does it strongly support it? It suggests it. I wouldn't say it strongly supports it. Because what's going to happen next, you'll see, is we're going to increase our level of confidence and things change. I'm just realizing I did the wrong problem for part B. I did a 90% confidence interval. Well, that's good. That'll support what I'm trying to do next. So let's do the 95% confidence interval. So all that's going to change is, instead of 1.645, we're going to replace that with the next z-score up, 1.96. And now if we calculate that, do that same arithmetic, so that's giving me a margin of error of 0.347 if I do some rounding. Now if I do those calculations, so I'm getting 5.85 up to as much as 6.547 if I round around it. Now with a 95% confidence interval, now we see that it includes the 6.5 value. So here we definitely can't say that the college students get less sleep on average. Granted, it's on the upper bound of it, but it does capture it, and there's a 95% chance we could repeat the sample and get an average that high. Okay, so that's the interpretation we can make with this. So to do part D now, they're asking us to find the sample size required to be 90% confident that of the sample mean and have the margin of error be within 0.2 hours. So if we take a look at that formula in the book, what that's telling me I need to, in order to find the sample size, I need to know whatever that particular z-score is for that level of confidence times the standard deviation with the population over the margin of error. And then once we do that calculation, we have to square the result. And then we have to round up. We have to make sure we go up to the next highest number. Okay, so let's do that calculation here. So I know, let's see, I've got a 90% confidence interval, so my z, my critical value for z is that 1.645, because that's associated with a 90% confidence interval. And then I'm going to multiply that by my standard deviation, which is 1.25. They told me that up here, right? And then I'm going to divide that by the margin of error. And the margin of error they're looking for is 0.2. And then I'm going to square that whole mess. So once I do that calculation, I'm getting 105.704, yada yada. So the sample size I would need would be, because I've got to make sure I catch it, 105 won't be enough. So I need 106 people to make this work, to be within that margin of error. Okay? Now, all that's different for the next part is we're going to change, instead of the margin error being 0.2, they want it to be 0.1. So we can just change that to be 0.1, do the same calculation, and that's giving me 422.8. So again, we get a round up. So 423 I would need. Notice by shrinking that margin of error, I need a larger sample size. The larger the sample size, the smaller the margin of error. You got to remember that. And then they want us to estimate the sample size for a 99% confidence interval. So everything's the same setup, except instead of 1.645, we're going to use 2.575. Hope that's all right, that I'm just crossing things out and not rewriting everything. But do that same calculation. So when I do that calculation, I'm getting a little over 1,000. Again, we get to round up, so I would need to have 1,037. Remember, the 1,036 isn't quite big enough. It's a little bit more than that. So what are some walkaways from this? Well, besides using the formulas and coming up with the confidence interval, as your sample size increases, so our sample size went from, well, actually, let's just look at the two where we kept the sample size, the confidence interval the same. Our sample sizes went from 106 up to 400 and something. And then when we increased our confidence interval, now I understand here we use three different margins of errors, or two different margins of errors. But look, if we look at these two, the margin of error stayed the same, but in order to keep it the same and increase the level of confidence, we had to get a much larger sample size. So larger sample sizes, smaller margin of error, a larger level of confidence. We have a larger margin of error, right? Because you need to account for more of that error possibility. Okay, hope that helps.